Hey guys, what's up? So in my last video, I showed you how to add a linear actuator to the back of a parabolic dish like this. In this video, I wanted to give you an update of the work on the electronics I've been doing. So here on this bench, I have a Raspberry Pi 3 and a motor controller. This one's from Adafruit. Also on the back of the dish, I have a 3-axis accelerometer that's right now just taped there. And that is connected to the Raspberry Pi, and it allows the Raspberry Pi to measure the elevation of the dish. So the Raspberry Pi, using that information, can drive the dish to any desired angle using this motor controller, which powers the linear actuator. The nice thing about this setup is I only have to run 12 volts DC out to it, because the data connection is over Wi-Fi, and I'm using a 12 volt to 5 volt step down converter to power the Raspberry Pi, and the linear actuator is also driven off of 12 volts. So I just have to run a 12 volt cable out to the dish and the electronics, which I'm planning on eventually putting in this waterproof box. And then I can get on my laptop and SSH into the Raspberry Pi and execute a simple Python script that moves it to any desired angle. Here I'm putting in 30 degrees. It must already be at 30 degrees, so let me put in 60 degrees. There. So yeah, it's kind of coming together. I have a lot more fine tuning to do of the motor controller, and then trying to get everything packaged nicely in this box. And I haven't even really started on the RF part of this. I have an LNB that I've already played around with a little bit, feeding it into one of these RTL SDR dongles, and so I need to figure out what I'm actually going to do with this RF signal once I get it into the Raspberry Pi. Just to start out, I'll probably just look for any kind of signal from a known satellite and see if I can just find it on the waterfall display. So still got a lot of work to do, but it's coming together, and I haven't even focused on azimuth control at all. Right now it can just move up and down elevation. I figured I'd try to get that working before I move on to anything else. So I'll keep you updated with that, but thanks for watching. I use this Adafruit Pi hat, which helps me just make some quick connections to the GPIO pins on the Raspberry Pi. I'm using I2C for the accelerometer here, and then just some GPIO pins that I can actually PWM them in software with the library in Python for the motor controller. And to power the Raspberry Pi off of the 12 volts DC, I bought this 3 amp 12 to 5 volt DC to DC converter from Adafruit. So pretty much everything electronically except the linear actuator so far I've gotten from Adafruit, so that's kind of nice. Here's the triple axis accelerometer breakout board I'm using, and right now I've just been electrical taping it to the back of this dish. Eventually I'll need a more mechanically secure connection, and also I'll need to weatherproof this somehow, and so that communicates over I2C through this cable to the Raspberry Pi. And here you can see the linear actuator and its power cable, which is running over to the motor controller. Here you can kind of see how the Python script currently works. You just put in 2 arguments. One of them is the desired elevation angle. The second argument is the maximum allowable error. Both of these are in degrees, so I can set this to go to 30 degrees with 1 degree of error. I'm going to press enter, it kind kind of shows the progress.